Hello class. Today we are looking at section 4.6, multiplying polynomials. Turn to page 275 and look at number 41. Page 275. 41 says multiply. I have negative 6x squared times 2x squared plus 3x minus 5. I'm going to use distributive property. I'm going to take the negative 6x squared and multiply it to all three terms in my parentheses. We do want to remember our property of exponent rules. And that rule says that when multiplying, I add the exponent. So we are definitely applying that when we are multiplying polynomials. Negative 6 times 2, we know is negative 12. Then you have x. 2 plus 2 is 4. So I have negative x, negative 12x to the fourth. Negative 6x squared times positive 3x. Negative times a positive, negative. 6 times 3, 18. Count the x's. 2 plus 1, x to the third. Negative 6x squared times negative 5. Negative times a negative is positive. 6 times 5, 30. And then we have x squared left over. And this is also how you will write your answer in standard form. Notice I went from 4 to 3 to 2. My degree will be 4. My leading coefficient is negative 12. And we have three terms here. Look at number 45. We are looking at a fraction. Negative 2 over 3 r squared t squared times 9r minus 3t. Right here, just take your time and work on this fraction. You can read this so many ways. You can simplify the 3 with the 9 and the 3, or just multiply and then simplify after. I want to do this a little at a time. Negative 2 times 9 is negative 18. Divided by 3 would give me negative 6. Negative 2 times 9 is negative 18. Negative 18 divided by 3 is negative 6. Now count your r's. I have r squared times r to the third. And then only thing left is t squared. A negative times a negative makes a positive. 2 times 3 is 6, and 6 divided by 3 will be 2. You have only r squared left over. Count your t's. 2 plus 1 is t to the third. When you are multiplying with the variables have to be the same, and then you add those exponents. So make sure that you remember that the bases have to be the same in order to add those exponents. Look at number 51. It says find each product. Now I know that the word product means the answer to a multiplication problem. We're going to apply the FOIL method. FOIL. We know F represents first, O outside or outer, I inside or inner, L for last. So you usually apply the FOIL method when you're dealing with binomials, and we know binomials are two terms. So they have a binomial times another binomial. We apply the FOIL method. FOIL is just distributive property. That's all it is. It's just distributive property. So do keep that in mind. Binomials have their own little special name, which is FOIL, but it's nothing but distributive property. 51 I have 5a minus 2 times 2a minus 3. And I do want to go over the FOIL again, which again is just distributive property. 4a and 2a will be first. 4a times negative 3 will be my outside. My inside will be negative 2 times 2a. And my last will be negative 2 times negative 3. So we're going to go over that a little at a time. First, 4a times 2a is 8a squared. Outside, 4a times negative 3, negative 12a. Inside, negative 2 times 2a is minus 4a. Last, negative 2 minus 3, positive 6. After this step, we do want to combine like terms. My like terms are usually my two inner terms. I have 8a squared minus 16a plus 6. If we are reviewing, my degree is 2. My leading coefficient is 8. My constant is positive 6. And I have a second degree trinomial. Number 57. U plus V times U plus 2t. There are a lot of different strategies for multiplying these. You can apply the box method, FOIL method. You can even work with algebra tiles to figure out how to work these particular problems out. But the quickest way to do a problem like 47 and 51 is just apply the FOIL method. That is the quickest way, and it works every time. We're going to apply the FOIL method again on number 57. U times U is U squared. U times 2t is positive 2tu. And I do tell students to usually put your answers in alphabetical order because that helps you when you're combining like terms. So just put it in alphabetical order. V times U is UV. Last, V times 2t is positive 2tv. On this one, are there any like terms? Well, I see a U squared, but nothing else says U squared. I see TU, nothing else says TU. UV, nothing else says UV. And then I see TV, nothing else says TV. So all four of these terms are unlike, so we don't combine anything. And that would be my final answer on number 57. Number 61. I have 3a times a plus b times a minus b. You are multiplying. Parentheses mean multiply. You can multiply however you like. You can multiply these two together, or these two together first, or this term and this part together first. It really doesn't matter how you multiply. I'm going to do 61 a little different, but it doesn't matter. I can distribute the 3a to a plus b, or I can apply 4 and then distribute the 3a at the end. It really doesn't matter. So I think that the way I want to do it is I want to distribute 3a to the a plus b first. And remember that when you multiply, you add the exponents. So 3a times a is 3a squared. 3a times b is plus 3ab. And it's still multiplied to a minus b. So I do want to keep it in parentheses to indicate I'm still multiplying. Now we're going to apply FOIL method. We're going to do first. So we have 3a to the third. We're going to do outer. I have minus 3a squared b. We're going to do inner. So that's positive 3a a squared b, and then we're going to do last, which is minus 3ab squared. I want to combine my like terms. So my like terms are in the middle, and they cancel out to 0. 3 minus 3 is 0. My final answer is 3a to the third minus 3ab squared. Look at number 65. I have 2x minus 3 times x plus 1 minus 5x times x plus 2. If you notice, I'm going to apply the FOR method on the first two expressions, and then I'm going to distribute the last two expressions. Applying FOR, 2x times x is 2x squared. 2x times 1 is positive 2x. Negative 3 times x is negative 3x. Negative 3 times 1 is minus 3. So when you're doing this, you can remember, and we talked about this on the last section, you can line up your variables, your like terms, vertically as well. So that's just doing, so we're just doing a different strategy. You can either keep everything horizontal, or you can line the like terms up vertically. It doesn't matter. Negative 5x times x is negative 5x squared. And again, notice I'm lining my like terms up as I'm doing it. So I'm doing two steps in one. Then negative 5x times 2 is negative 10x. So I do want you to keep in mind how I am lining up all the like terms. The x squares are together, all the x's are together, and then a constant is by itself. Another thing I want you to pay attention to on 65 is that when I apply the distributive property, I also multiply the negative into the answer. Very important. Now, 2 minus 5 is negative 3x squared. I have 2 minus 3 is negative 1x. Negative 1x minus 10x is negative 11x minus 3. And that's my answer. Reviewing again, my leading coefficient is negative 3. My constant is negative 3. My degree is 2. And it's a second degree trinomial. Number 71 says find each product. Again, we know product means the answer to a multiplication problem. So 71, I have 4t plus 3, and it's raised to the second power. We have to keep in mind that the base is 4t plus 3 because it's in parentheses. And the exponent is 2. That means we write out 4t plus 3 2 times. And of course, I see a 2 by 2, 2 terms here, 2 terms there, a binomial. I'm going to apply FOR method. So I have my first, which is 16t squared. I have my outside, which is plus 12t. My inside, 3 times 4t, is positive 12t. And my last, 3 times 3, is 9. Combine like terms. So my final answer is 16t squared plus 12 plus 12 is 24t plus 9. So far we've talked about how to do the FOR method. And the FOR method works great when you're looking at a 2 by 2. Well, what if you have a case where you're looking at a 2 by 3 or a 3 by 3, a trinomial times another trinomial, or it can be a 3 by 4. So, FOR method doesn't work as well with those types of polynomials. When those type of polynomials appear, I personally like using the box method. You can still distribute out a problem like number 79, but in my opinion, the box method is quicker and it's easier to see what's going on. I see a 2 by 3. I see a binomial times a trinomial. I want to apply the box method, so I'm going to draw a box. It doesn't matter how I draw the box. I can draw 2 rows, 3 columns, or 2 columns and 3 rows. It doesn't matter. Just draw a box. So I want to do a 2 row, 3 column, a 2 by 3. In my 2, I'm going to say 2x plus 3. That's the given problem. And then I'm going to say x squared plus 4x minus 1. You can use distributive property still. All you have to do is say 2x times x squared, 2x times 4x, 2x minus 1. Write those terms down. And then you go back and say 3x times x squared, 3 times x squared, 3 times 4x, and 3 times negative 1. And write those terms down and then combine like terms. But me personally, I like the box method because it's quick and easy and I can see everything I need to see to find my answer. On the box, you multiply the row to the column. Let's see it. So 2x times x squared would be 2x to the third. I'm going to put these two together. So 2 times 4x, it'll be 8x squared. I'm going to put these two together. Negative 1 times 2x is negative 2x. I'm going to put these two terms together. So 3 times x squared is 3x squared. I'm going to put these two together. I have 12x. And then finally I'm going to move these two together, which is negative 3. Super quick. And I'm done with that part. Now, we're going to combine like terms. If you do your box method correctly, most of the time, your like terms are going to be at an angle. So do you see how the like terms are at an angle? And that's a good way to let you know you did it right. It's not always. It's not going to always turn out like that. But for most cases, it will. We're going to start writing the answer in standard form. So we know what standard form means. You start with the degree and then you go all the way down to your constant. So if you're writing the answer in standard form, we're going to start off with the 2x to the third. And then 8 plus 3 is plus 11x squared. 12 minus 2 is plus 10x. And then you minus that 3 at the end. Super easy, and it makes a lot of sense. If you look up some research on algebra tiles is very similar to what you see on the box method. A little more complicated, but it's very similar to that box method. You're looking at the rows with the columns and putting them all together. And that's it. Now, on number 79, you can also do it another way. So we are going to go do it the long way. And then you can give me some feedback on which strategy you like better. And if I do it correctly, I should get the exact same answer. On number 79, I'm going to take the 2x and multiply it by all three terms. 2x times x squared is 2x to the third. 2x times 4x is positive 8x squared. 2x times negative 1 is negative 2x. Now, I'm going to go and multiply everything by 3 now. 3 times x squared is positive 3x. And notice, as I'm doing this, I am combining my like terms. 3 times 4x is positive 12x. And then 3 times negative 1 is negative 3. And then we're going to answer the problem. So my final answer is 2x to the third plus 11x squared plus 10x minus 3. And that is my answer. Same thing as doing the box method. Again, I like the box method personally, but you can either distribute out the 2x and the 3 and then combine like terms, or you can apply box method. So please let me know what you think, which strategy you like the best. I'm going to, let's look at number 89. 89 says solve each equation. So on 89, first of all, how do I know that this is an equation? I know that 89 is an equation because I see an equal sign. I see my equal sign, though it's an equation. So my goal is to get the z by itself. I see z a lot of times. I only want to see one z at the end. We're going to go ahead and distribute and apply for a method. Z times z is z squared plus 2 times z, 2z, equal. Now, right here, we're going to talk about the word conjugate. So the word conjugate means that the terms are the same except the signs in the middle are different. When it's a conjugate, you are going to apply the forward method, but you only multiply the first and the last because the outside and inside will equal 0 every time. So when you run across a problem that has a conjugate, you only multiply the first and the last because the outside inside is going to equal 0 every single time. But just try it out and see what happens. But I know that because they're conjugates, I only need to say z times z, which is z squared, and then I'm going to jump to my last. 4 times negative 4 is minus 16. I don't have to do anything else because the outside inside is going to cancel out to 0. So that's all I need to do with that. Now, I still see a lot of z's. So I want all my z's on one side of my equation. I'm going to put everything to the left. Now, if we remember about solving the equation, I'm going to say z squared. If I move this z squared from the right to the left, the sign changes. And then I have plus 2z equal negative 16. Now, z squared minus z squared equals 0 because they are opposites. And opposites equal 0. So 2z equal negative 16. Divide both sides by 2. So z equal negative 8. And one thing that's wonderful about solving equations is that you can take your answer, which is negative 8, and plug it back into my original equation, and the left side will equal the right side. If they equal, I know that I answered this question correctly. That's the difference between an equation and an expression. Equations are always better because equations they can be harder, but they can be better because you can at least go back and check your work to see if you did it correctly. So on this section, definitely try a few more problems throughout these notes to make sure you get it. One observation I do want to make that you will see on your homework is that when it says write the answer in standard form, you write it from the highest exponent down to your constant. Another observation on homework is that you may run across a problem that says x plus 2 times x minus 3 times 2x plus 4. You may run across problems that look like that. Don't panic. You multiply 2 at a time. So what you will do is you can either keep x plus 2 and then you can FOIL out the last 2. Doesn't matter which order you go in because you're going to get the exact same answer. So if I FOIL out the second 2, I'm going to have 2x squared first, outer plus 4x, inner is minus 6x, and then my last is minus 12. And then from there I got x plus 2 times 2x squared minus 6x minus 12. And then from here, you can either, you have a 2 by 3. So you can either distribute out the x and the 2, or you can apply box method. So when you see 3 binomials multiplied together, just multiply 2 at a time. It doesn't matter where you start, multiply 2 at a time. You're going to end up with a 2 by 3 or a 3 by 2. And then you just keep working it out from there. You may also run across a problem that looks something like this. You may run across a problem that says x minus 1 to the 4th power. But we know what that means. We know that means you write x minus 4 out 4 times. So right here, you will multiply these two together and then multiply these two together. And then once you find those answers, you will have a 3 by 3. And you can either distribute out the 3 by 3, or you can write a 3 by 3 box and start working it out using that box method. So just keep that in mind as you're looking at your homework, that when you see multiple expressions multiplied together, just multiply 2 at a time. Okay, so that is section 4.6, multiplying polynomials. If you have any questions or concerns, please let me know.